Hello viewers, in today's session we are going to discuss the solution of this equation, which is the sum of two mod functions, right? And here in the left hand side we have the sum of two mod functions, that is mod of x minus 2, and here we have mod of 3 minus x, and in the right hand side we have 4, right? So let us see the method how we can find out the solution of these kind of equations where we have the sum of two mod functions equal to some positive number, right? So let us use the method of intervals, right? So before applying the method of intervals to find out the solution of this equation, let us first quickly define mod of x minus 2 and mod of 3 minus x using the definition of mod function, right? Now see, mod of p is defined as positive p whenever p is a positive number, and mod of p is 0 whenever p is equal to 0, and mod of p is equal to negative p when p is less than 0. So this is the definition of mod function which we are going to use to define mod of x minus 2 and then mod of 3 minus x. So mod of x minus 2 can be defined as positive x minus 2 whenever x minus 2 is greater than 0, right? So this implies x is greater than 2, and mod of x minus 2 is equal to 0 whenever x minus 2 is equal to 0. So this implies x is equal to 2. So when x is equal to 2, mod of x minus 2 is equal to 0. And similarly here, mod of x minus 2 is equal to negative of x minus 2, that is minus x plus 2 when we have x minus 2 less than 0. That is solving this inequality, we have x less than 2, right? Similarly, we can define mod of 3 minus x. So mod of 3 minus x is positive 3 minus x whenever 3 minus x is greater than 0. So this implies x is less than 3, right? And mod of 3 minus x is equal to 0 when 3 minus x is equal to 0, that is when x is equal to 3, and mod of 3 minus x is equal to negative of 3 minus x, that is minus 3 plus x whenever 3 minus x is less than 0, and this implies x is greater than 3. So this is how we can define mod of x minus 2 and mod of 3 minus x, because we are going to make use of these two results while solving this equation. So the first step is to define mod of x minus 2 and mod of 3 minus x. And the second step is to get the critical points. So here inside the mod function symbol, we have x minus 2. So the critical points can be obtained by taking x minus 2 is equal to 0. And here we have mod of 3 minus x. So we can now write 3 minus x is equal to 0. So solving these two equations, we get x is equal to 2 and x is equal to 3, right? So these are the two critical points here. And the third step is to draw the real number line. So here we have minus infinity, here we have plus infinity. And now let us locate these two points, or the critical points on the real number line. So here we have 2 and here we have 3, right? Okay, so now when we locate these two points on the real number line, then we can see that these 2 points divide this entire real number line into three intervals. The first one is from minus infinity to 2, and the second one is from 2 to 3, and then we have here the third interval is from 3 to infinity, right? So now here we'll discuss the values of x, or the nature of x in these three intervals, right? So let us first take this interval. So here we can take x greater than minus infinity but less than 2. In this case, we'll take x is greater than or equal to 2 but less than or equal to 3. And in this interval we have x greater than 3 but less than infinity, right? So now let us first take this one, that is this interval. X is greater than minus infinity but less than 2. So now when we take x greater than minus infinity but less than 2, then mod of x minus 2 is equal to negative of x minus 2, that is minus x plus 2, because here the condition is x less than 2, and here we have x less than 2. So we can now replace mod of x minus 2 by negative of x minus 2, that is minus x plus 2. And here we have mod of 3 minus x. So here in this case we'll write mod of 3 minus x equal to positive 3 minus x, because x is less than 3, and here we are taking the interval x is less than 2. So here a mod of 3 minus x is simply 3 minus x, and here we have 4. So now we have this linear equation. So we have minus 2x, here we have 5, here we have 4, and we can now write minus 2x is equal to 4 minus 5, that is equal to minus 1. So x is minus 1 over minus 2, that is 1 over 2. So taking this interval, we have the value of x as half, right? And so now x is equal to half. It belongs to this interval, that is minus infinity to 2. So we can take the first solution of this equation as x is equal to half, and we can also verify that x is equal to half is a solution of this equation, because the left hand side of this equation is mod of x minus 2 plus mod of 3 minus x. So taking x is equal to half, so we have now half minus 2, then we have 3 minus half, and here we have half minus 2 is minus 3 over 2, and here we have 6 minus 1, that is 5 over 2. So mod of negative of 3 over 2 is plus 3 over 2, and here we have 5 over 2. So we have 3 plus 5 over 2, that is 8 over 2, that is 4, right? So here we have the right hand side, right? So x is equal to half is a solution of this equation. Now let us consider the second interval. So now consider this interval x is greater than or equal to 2 but less than or equal to 3, and let us define mod of x minus 2 and mod of 3 minus x in this interval, right? So here we have x greater than 2. So when x is greater than 2, then mod of x minus 2 is positive x minus 2. So replacing mod of x minus 2 by positive x minus 2, we have here x minus 2, and then here we have x less than 3. So when x is less than 3, then mod of 3 minus x is equal to positive 3 minus x. So here we have simply positive 3 minus x, and this is equal to 4, right? So now we have x minus 2, then we have here 3 minus x is equal to 4. Now we can see that here we have positive x, here we have negative x, so these two get cancelled, and here we have 3 minus 2 is equal to 1, and here we have 4. So when we take this interval x greater than or equal to 2 but less than or equal to 3, then we arrive at this result, that is 1 is equal to 4, which is a false statement, right? So we'll discard this interval, that is no solution exists in this interval, right? So here there is no solution of this equation in this interval, right? So now let us consider the third interval. So in the third interval, we have x greater than 3 but less than infinity, right? So here let us now again define mod of x minus 2 and mod of 3 minus x in this interval. So here we have x greater than 3, right? And here we have x greater than 2, right? So mod of x minus 2 is now equal to positive x minus 2, because here we are considering x greater than 3. So whenever x is greater than 3, then mod of x minus 2 is equal to positive x minus 2. So here we have positive x minus 2, and then we have mod of 3 minus x. Now see, x is greater than 3. So when x is greater than 3, then mod of 3 minus x is negative of 3 minus x, that is minus 3 plus x. So here we write minus 3 plus x, and here we have in the right hand side 4. So now we have to solve this linear equation. So x plus x is 2x, and here we have minus 2 minus 3 is minus 5, and here we have 4. So we have 2x is equal to 4 plus 5, taking minus 5 to the right hand side. 2x is equal to 9, and x is equal to 9 over 2, that is 4.5, right? And we can see that 4.5 or 9 over 2, it lies in this interval, that is this value of x, that is 9 over 2, belongs to this interval, that is 3 to infinity, right? So our second solution of this equation is given by x is equal to 9 over 2. So when we use the method of intervals like this, then we can see that the solution occurs in this interval, that is minus infinity to 2 and 3 to infinity. So when we take minus infinity to 2, we have the solution x is equal to half. When we take 3 to infinity, we have the solution 9 over 2. We'll also verify this solution. And when we take 2 to 3, then we arrived at this result, that is 1 is equal to 4, which is a false statement because 1 is not equal to 4. So no solution exists in this interval. So now let us verify this solution by taking x is equal to 9 over 2 in the left hand side of this equation. So the left hand side is mod of x minus 2 plus mod of 3 minus x, taking x is equal to 9 over 2, and here we have 3 minus 9 over 2. So here we have 4, 9 minus 4 is 5, so we have 5 over 2, and here we have 6. 6 minus 9 is minus 3 over 2, and mod 5 by 2 is 5 by 2. Mod of minus 3 over 2 is positive 3 over 2. So we have 5 plus 3 over 2, that is 8 over 2, and this is equal to 4, that is equal to the right hand side. So this verifies that x is equal to 9 by 2 is also a solution of this equation. So here by using this method of intervals, we have arrived at two solutions of this equation, that is x is equal to half and x is equal to 9 over 2, and x is equal to half, it falls in this interval minus infinity to 2, and x is equal to 9 over 2, it falls in the interval that is 3 to infinity, and no solution exists in this closed interval that is 2 to 3, right? So viewers, this is how by the method of intervals we can easily solve these kind of equations in which we have the sum of two mod functions.